Hello, we're the team number 2. We're going to explain the problem number 2. This is our math project from second portion. Our team is composed by me, Ricardo Camarena, Ian Huerta, and Frida Flores. Our teacher is Tiberio Cabral.
This is an area's problem, so this is our original function and these are our steps. First, the graph, integrate with respect with x or g, draw approximate rectangle, integration method, calculate the area, and first step, the graph. And we can see the vertical lines that goes from minus pi to pi. The color section is going to be our area. This is a function with respect of x, so we're going to integrate with respect to x.
The thinner the rectangles are, the closer to the area they will be. This is if we fill the area of the curve of the rectangles, we can obtain a similar form.
We have to calculate the antiderivative, and we designate x as u and sine of x as dv. We already have u, which the derivative is going to be du equals to dx, and sine of x as it is dv. The integral will be b, which is minus cosine of x. And we put this together in this formula, which is u times b minus the integral of du times b, and the result is that the antiderivative of f of x is sine of x minus x cosine of x plus c. And for step E, we have to define the area using definite integrals and the first theorem of calculus. The definite integral is this function, well, this formula, which is a simple integral but with a lower value and a high value. The result is indifference of integrating something like normal way, is that we have to put the antiderivative of the function minus the antiderivative of the same function but evaluated in a and b. If we substitute the values of a and b, we're gonna get minus pi and pi as a and b. The function is the same function as here, and this is gonna be equal to those factors, which is evaluating sine minus cosine times x, but with the respect values of a and b, which is minus pi and pi. The final result is 2 pi, and this represents the units of area. Those units of area are the shadowed area in the graphic, which is this part and this part. So,
In conclusion, we can say that these types of solution, the use of definite integral and first theorem of calculus, can be useful to know the dimension that a certain material can be in the space. It could be measured in liters, kilograms, or other units. That's why our problem is on units of area. It's not definite because it's represented in a graph, and it didn't have this type of specification like it's a liquid or solid component.